Good morning, students. I am Dr.R.SUGANYA, Assistant Professor, Department of Computer Science with Cybersecurity. Today, we are going to talk about duplication and preservation of digital evidence. The three criminal evidence rules to gain admissibility are authentication, the best evidence rule, exceptions to the hearsay rule. Authentication means showing a true copy of the original. Best evidence means presenting the original, and the allowable exceptions are when a confession or businesses or official records are involved. Authentication appears to be most commonly used rule, but experts disagree over what is the most essential or most correct element of this practice. If preservation is poor, it becomes fairly evident that your collection and transportation of evidence gives rise to numerous possibilities for error in the form of destruction, mishandling, and contamination. Problems in the preservation area have implications for the integrity of law enforcement and crime labs. The basic chain of custody, for example, involves at least three initial sources of error. Computer evidence processing steps. Computer evidence is fragile by its very nature, and the problem is compounded by the potential of destructive programs and hidden data. Even the normal operation of the computer can destroy computer evidence that might be lurking in unallocated space, file slack, or in the Windows swap file. There are general guidelines provided as food for thought. Shut down the computer, document the hardware configuration of the system, transport the computer system to a secure location, make bitstream backups of hard disk and floppy disk, mathematically authenticate data on all storage devices, document the system date and time, make a list of key search words, evaluate the Windows swap file, evaluate file slack, evaluate unallocated space, search files, file slack, and unallocated space for keywords. Document file names, dates, and times. Identify file, program, and storage anomalies. Evaluate program functionality. Document findings. Retain copies of software used. Legal aspects of collecting and preserving computer forensic evidence. In simple terms, a chain of custody is a roadmap that shows how evidence was collected, analyzed, and preserved in order to be presented as evidence in the court. So, a clear chain of custody, we can say, to no information has been added or changed, no complete copy was made, a reliable copy process was used, all media was secure. Legal requirements. So, individuals use a computer system without authority and having all their activities on the system to be monitored and recorded by system personnel. So in the course of monitoring individuals improperly using the system or in course of system maintenance, the activities of authorized users may also be monitored. Anyone using the system expressly consents to such monitoring and is advised that if such monitoring reveals possible evidence of criminal activity, system personnel may provide the evidence of such monitoring to law enforcement officials. Evidence collection procedure. Who initially reported the suspected incident along with time, date, and circumstances surrounding the suspected incident. Details of the initial assessment leading to the formal investigation. Names of all persons conducting the investigation. The case number of the incident. Reasons for the investigation. A list of all computer systems included in the investigations along with complete system specification. Network diagrams, applications running on computer systems previously listed, a copy of policy or policies that relates to accessing and using systems previously listed, a list of administrators responsible for routine maintenance of the system, an access control list of who had access to the collected evidence, what date and time. Storage and analysis of data, the data and time of analysis, tools used in performing the analysis, detailed methodology of the analysis, results of the analysis. Computer image verification and authentication. Special needs of evidential authentication. A wealth of mathematical algorithms deal with secure encryption, verification, and authentication of computer based material. These display varying degrees of security and complexity, but all of them rely on second channel of information whereby certain elements of encryption, decryption, or authentication processes are kept secret. This is characterized most plainly in the systems of public and private key encryptions, but is also apparent in other protocols. Consider the investigative process where computers are concerned. During an investigation, it is decided that evidence may reside on a computer system. It may be possible to seize or impound the computer system, but these risk violating the basic principle of innocence until it proven guilty by depriving an innocent party of the use of her system. Digital IDs and authentication technology, and we have the security warning screen and client application security warning systems. So it verifies a particular digital ID process, and publisher obtains a software developer digital ID from sign and encrypts a hash using this private key and using the publisher's public key contained within publisher's digital ID. Timestamping, because key pairs are based on mathematical relationship that can theoretically be cracked with a great deal of time and effort, it is a well established security principle that digital certificates should expire. Verification sign will expire 1 year after it is issued. However, most software is intended to have a lifetime of longer than 1 year. To avoid having to resign software every time the certificate expires, a timestamping service is now available. Now, when signed code, a hash of code will be sent to verify to be timestamped. Practical considerations. Thank you.